Hey everyone, we've made it to the last section in chapter 7.7. Still solving some equations, but they involve inverse trig functions. So we're going to need some things for this section, namely the unit circle, and then that chart with domain and range for inverse functions. So I'll put those on here from previous sections, but we'll refer back to those. So the first type of example you'll see is kind of a multiple choice. Yay, multiple choice. Which of the following equations has a solution of 3 pi over 4? For these, you really have to pay close attention to this table here. So all of these are kind of close, but just make sure the value falls within that interval here, right? So we can go one by one and just take a look. How about arctan of -1, that first one? If I look at the arctan, notice its interval, your answer has to be between -pi/2 and pi/2. 3 pi/4 is not in that range, so I know that one cannot be right. How about arc cosine of -√2/2? So if I look at arc cosine, okay, well, that's a possibility. Yeah, between 0 and pi. And so what I want to check is, does the cosine of 3 pi/4 equal -√2/2? Are those two values linked in the unit circle? All right, so I can glance up at my unit circle, and at 3 pi/4, yeah, I see that the cosine is -√2/2. So yes, that one does have a solution of 3 pi/4, so I could circle that one. Arc sine of √2/2, nope, that one's not going to work, because if I look at the arc sine, again, the interval is not going to contain 3 pi/4, so that one's out. Secant √2, well, that one is close, but it's a positive number here, right? Anything positive is going to be in the first quadrant, and 3 pi/4 is in the second quadrant. So I know that one cannot be right. The next one, arc cotangent of -1. Okay, so arc cotangent. Okay, we got 0 to pi there, so 3 pi/4 is in that range. So let's investigate further. Does the cotangent of 3 pi/4 equal -1? So I can go back up to my unit circle, and cotangent is 1 where the x and y values are equal. So that's this one, that one, right? That's where cotangent will be 1. It will equal -1 here and here because x is negative and y is positive, or vice versa. So yeah, cotangent of cotangent of 3 pi/4 does equal -1. That's that right there. I'm highlighting everything. Okay, that's that section. I can barely see it anymore. So sorry about that, but yeah, it's 3 pi/4, -1. We're good. So that's another answer. That's gonna work. And then finally, cosecant, if I look at its interval, nope, 3 pi/4 is not in that range. Okay, so I know that one's not it. So those are the only two. Okay, so that's how those work. We could try another one. How about which one has the solutions of pi? Okay, so does arc cosine of -1 equal pi? So first I'll look at arc cosine. It's got a little mess here with all my highlighting, right? Let's start over. Arc cosine, 0 to pi. Okay, so pi is in there, so I have to investigate further. And then how about the cosine of pi? Does that equal -1 on the unit circle? So pi, -1, cosine is the x coordinate. So yes, that one is a solution. I can circle it. Arc sine, well, if I look at arc sine, my interval is here. It does not contain pi, so it cannot be a solution. Arc sine, so that eliminates both of the signs. So those middle two are wrong. How about this last one, arc cosine of 1? Well, if it's positive, it's going to be in quadrant 1, and pi is not in quadrant 1, so that cannot be a solution. Okay, so that one just had the 1. Okay, Now we're going to get into solving some equations for x. And there's an interval given. For these, you don't really have to be concerned too much with the interval. It's more of a technical thing. But what you're really going to be doing is solving that equation, trying to isolate the x. So we're just taking that equation and using, really this is algebra, mostly, isolate the x. Okay, so the first thing I would have to do on that one is divide both sides by 6. Right? And so now I have y over 6 equals cosine x. Okay. And then now how do I isolate x, get x by itself? Well, here's the trick. I mean, you can't like do something crazy like divide out the COS, right? Because that's not a multiplication, it's a trig function here, cosine of x. But if you have cosine on one side, you can move the cosine to the other side as long as you put an inverse on it, right? So I'm going to write cosine inverse or arc cosine of y over 6 equal x. And then that's it, right? So there's my final answer. Okay, so there's the little trick. And then this again, just technicality, notice we didn't use it, but this equation is only true in that interval, right? Going back to those restrictions from that table on the first page. Okay, how about the next one? Well, my first thing is I gotta divide both sides by 8, right? So now I've got y over 8 equals sine 2x. Okay, now I'm gonna strip off that sine. So I'm gonna put that to the other side. That's gonna be now sine inverse y over 8. But what I'm left with is 2x, right? And so then finally to get x by itself, I gotta get rid of that 2, and I would probably just do that by multiplying both sides by 1/2. Right? And that cancels that 2 out over there, right? And that'll give me my final answer. So my final answer is 1/2 sine inverse y over 8. That's equal to x in that interval specified above. Okay. So these aren't too bad, huh? How about this last one, or this number 5, I guess, in this page? I'm going to move that 2 over, right? So that's actually like subtract 2 on both sides. So I'm going to have y minus 2. So again, that's just algebra there, because it's 2 plus, not 2 times. So I got to subtract it. And then my little trick to get rid of that tangent, put tangent inverse on the other side. And I got it. That one didn't take too long. Okay, finally, solve each equation for exact value solutions. We got a few of these. Okay, so for this one, I'm going to try to isolate the trig function, or the inverse trig function. I'm going to divide both sides by 6. So now I've got arc cosine x equals 5 pi over 6. Okay, and now I got to use the unit circle. The cosine of 5 pi over 6 is what, right? That's the same as saying arc cosine of what is 5 pi over 6. Okay, so which value, which x coordinate on the unit circle is linked with 5 pi over 6? So I'd go back up to my unit circle, find 5 pi over 6. Let's get rid of the mess. Where's 5 pi over 6? There it is, right? And that's linked with the x coordinate of negative 3 pi over 2. So that's it. It's got to be it. So here I'd have x equals negative, what did I say, 3 pi over 2? No, root 3 over 2. Oof. Sorry, misspoke. So there's my final answer. The cosine of 5 pi over 6 is negative root 3 over 2. Same as saying arc cosine of negative root 3 over 2 equals 5 pi over 6. Those two things are linked together by the cosine function. Okay, how about number 7? So I'm going to try to, again, isolate that sine inverse function. So for this one, my first step is going to be multiply both sides by 3/4. Right, because that cancels out the 3 and the 4. Little algebra there. So now we've got sine inverse of x over 8 equals 3 pi over 4. Right? Okay. Now what? Well, you know what I would like to do on this one is, because I have that little 8 in there that's messing me up, I'm going to move the sign to the other side. Right? If you move that trig function, it just, if it's inverse, it becomes non-inverse. Right? X over 8 equals sine 3 pi over 4. So there's a cool little move. And then now I can use the unit circle. What's the sine of 3 pi over 4? So 3 pi over 4, right there. The sine is the y coordinate. That's root 2 over 2. So I can replace all that with root 2 over 2. So I have x over 8 equals root 2 over 2. And then finally, to isolate the x, I'm going to multiply both sides by 8. Cancels there. 2 goes into 8 4 times. So final answer, x is going to equal to 4 root 2. Okay, and then I'm done. Okay, there's a good little breaking point. I'm going to stop there and I'll do that last page in the next video. But I hope those go well for you. Kind of a shorter assignment for this last section. And then we'll move on to chapter 8. Okay, send questions my way if you have any. Bye.